Satya will be speaking about the past, the present, and the future of OpenCV. Do you want this mic or you want to use the podium?
I'll use that. Right. Thanks, Ramon.
And this is the clear.
Yeah. Thanks, Ramon. So today I'm going to speak about OpenCV, the struggles and the promise of open source AI. Now, before we do that, just as a way of introduction, I wear many hats. I'm the CEO of OpenCV.org. That's my charity work. I'm also the CEO of Big Vision, which is a consulting company in computer vision and AI. And I'm a blogger at learnopencv.com, which also produces tutorials on OpenCV, PyTorch, TensorFlow, and several other things. So let me take you back to 2005 DARPA Grand Challenge for autonomous vehicles. So this Grand Challenge started with pretty early in the morning. The first vehicle was the Highlander from CMU. This was supposed to actually win the DARPA Grand Challenge, but there was this other car from Stanford called Stanley. People could visualize the Grand Challenge on this UI, and Stanley takes over Highlander, and you can see it on this LiDAR view. Stanley goes through this pretty treacherous route, which didn't have GPS, so all the navigation was done using computer vision, and finally Stanley won the DARPA Grand Challenge in 2005. So a lot of people know about this story about Stanley winning the DARPA Grand Challenge and creating this revolution in autonomous driving. What people don't know is that Stanley was powered by OpenCV. The computer vision library that Stanley was running was OpenCV. So what is OpenCV? A lot of you probably already know about OpenCV. It is the biggest computer vision library in the world. It's a collection of 2,500 different algorithms. It's very popular in embedded vision community. 89% of the embedded vision engineers use it as the primary computer vision library. It has about 2 million installs per week. So it's 2 million installs per week. Pretty large user base. And it has over 70K stars on GitHub. Now, the founding principle of OpenCV was that it has to be open source and also optimized code, right? The code was optimized for real-time computer vision. The code had to be portable. That is why it was written in C in the beginning. And it had to be free, as in free even for commercial use. And that has created some problems for us lately. Now, OpenCV at a glance, it is a very large collection of libraries divided into different modules. We have some core functionality, which takes care of the data structures, matrix operations, etc. We have a high GUI, which is a very simple user interface for OpenCV. And then there are different modules for image processing, image transforms, some curve fitting, optical flow, standard, traditional computer vision algorithms. We have modules on segmentation, calibration, visual SLAM, and then also depth processing, RGBD processing. We have a deep neural network module, which is used by people to run inference on any standard deep neural network. And then we have a computational photography module. So, but each one of them is pretty big. There are several algorithms inside it. Total collection is about 2,500 different algorithms implemented in OpenCV. So the history of OpenCV starts back in 1998 when Dr. Gary Bradsky started this library at Intel. It was called libcv at that time, and it was released to the public in 2000, and the name OpenCV, Open Computer Vision, was adopted. It was part of, the release was done at CVPR in the year 2000, and then I just talked about the DARPA Grand Challenge, which was a big moment for OpenCV, and then in 2006, the first version of OpenCV was released. This was OpenCV 1.0. This was basically a C library which was released for all major OSs, a very big deal at that time. And then in 2006, companies Willow Garage and Itzies took over the maintenance of OpenCV. 2009, the mobile and Python versions were released. And Python, it was a very big deal at that time because Python was growing as the library of, as the language of scientific computing. It nearly doubled the usage of OpenCV. And today, I think Python is more commonly used with OpenCV than the original C++. In 2012, OpenCV.org came into existence, where it's a nonprofit foundation that maintains the OpenCV library. And at the same time, we also moved to GitHub for source control. 2015, OpenCV 3.5 came out with transparent API, which allowed CPUs and GPUs to be treated transparently, so you can write a single piece of code. The OpenCV library would take care of where the code will run and how to optimize it for CPUs and GPUs. And in 2016, the development team went back to Intel because the company that was maintaining the OpenCV library, ITSEs, got acquired by Intel. And the same year, the DNN module was also released. This is the deep neural network module, and JavaScript support was added. Now, 2018, we released OpenCV 4.0, which supports C++ 11, and it also added a lot of acceleration for Intel hardware, added features like QR code recognition, 3D reconstruction algorithms, etc. And in 2020, we started distributing the development of OpenCV. There is OpenCV China, a team that helps us out of China. There is Experience AI and OpenCV AI, OpenCV.ai, which help us maintain the library as well. Now, we are in 2023 and still not released OpenCV 5. So what went wrong, right? Where is the struggle coming from? Turns out, before I discuss that, let's discuss what is the wish list for OpenCV 5 and what's coming in OpenCV 5. First of all, we want to greatly expand the deep neural network module. We will add new data structures like 0D and 1D tensor support for deep learning, modern deep modules, models. And then we want new data types like 64-bit integers, Booleans, and bfloat 16. We want faster implementation of transformer architecture. We want to add multimodals like architectures like diffusion models and CLIP, and state-of-the-art support for ONNX, which is the standard for sharing deep neural networks. We also want to implement large image processing properly. So OpenCV was not developed for large images. So images, let's say 6K by 6K or higher, there is no support for OpenCV in that realm. So people have to tile the images and do all kinds of funny things. So we want to add native support for large images as well as speed up algorithms for large images using parallelization. We want to have support for scalable SIMD architectures like RISC-V and ARMv8+. And as you know that because of our history with Intel, most of the optimizations are done for Intel architectures, some NVIDIA, but we want to expand that to other architectures. Calibration, OpenCV has a very good calibration module for pinhole single camera, but we want to expand it to fisheye camera calibration as well as multi-camera calibration, and also add tutorials, etc., to help. Native support for depth cameras, that's coming. A lot of companies are helping us in that. We also want to add more algorithms for point cloud processing, and 3D visualization support is also coming. In HiGUI, which is the user interface for OpenCV, we are adding TrueType support with full Unicode support, and better 2D and 3D visualization. Improved OpenGL-based 3D visualization is also coming. And finally, OpenCV, any library is only as good as how easy it is to install on various platforms, and OpenCV is not great on that front. It is portable, but it's typically very difficult to install on various platforms. So we are going to natively support Android and better support for Raspberry Pi and Jetson, and increase our support for OpenCV Python with OpenCV 5. Now, because this library is about 22 years old now, there is a lot of legacy code that needs to be moved out of the library, main repository, into a side repository called OpenCV contrib. So we will remove support for OpenCV 1.x C kind of APIs in OpenCV 5 and remove some of the obsolete algorithms into OpenCV contrib so that it is still usable, but it is not part of the main library and the size of the library can be reduced. And finally, we are thinking about a tutorial and documentation. And for that, we are going to use large language models so that we can auto-generate some of these tutorials as well as a documentation. So we are going to fine-tune a large language model on OpenCV, tutorials, documentation, etc. So this is going to be a really fun project. Now, how do we fund OpenCV 5? But before we go there, let me explain why do we suddenly need more funding. For the longest time, OpenCV has been supported by Intel. And in 2020, we had the pandemic, which slowed down our development. We also had this conflict in Russia and Ukraine. And because of that, the Intel team in Russia was helping us. Half of the OpenCV team was part of Intel Russia. And when Intel pulled out of Russia, we lost half of our development team. And that was a big deal. And so we decided that, OK, we have to do something to fund OpenCV 5. So this is the annual budget that is needed for OpenCV, about $1 million only for the developers. 50% of it we want to get from corporations and 50% from individuals, right? We had a meeting of OpenCV in Turkey trying to decide what should be the path forward. And there were three options. The first option was to ask the community, the corporations as well as individuals for help. The second was a moral license. This was suggested by Gary Bradsky. I really liked it, but the developers shut it down. The idea was to include a license that says, you can use it for free, even for commercial use, but you should pay, right? And that just, whether or not it would actually have mattered, I really liked that idea, but the developers shut it down. I also was in favor of a commercial license for OpenCV 5. This was also shot down. That, OK, you can use it for non-commercial use and academic use, but for supported version, you should pay. So now we are left with the only version that we all agreed on, that we will ask the community for help. So right now, OpenCV is supported by various membership and partnership programs. The gold members are Intel, Microsoft, Google, FutureWay, and Huawei. This is 100K or equivalent in developer time and other resources. We have silver members, RoboFlow, Hackster.io, and RunPod. And these are mid-sized companies which are supporting with about 30K per year in funding. And finally, we have bronze members. Thank you, Drone Code Foundation. Big shout out to them. And as we speak here, Intuitivo is another company out of Argentina. This is a very small company, but they decided to help us out. And as we speak today, last night actually, Tangram Vision, they came up with a check for 6K. I don't know why they wrote a check, but they literally wrote us a check. I got them drunk. That's what happens at conferences. Thank you. And then we have development partnerships. There are companies who want to have specific features in OpenCV, and they can contact us, and we help them add those features to OpenCV. And this starts at 50K per year. We also have licensing partners. OpenCV.ai is the consulting arm of OpenCV, and they kick back some of their revenue back to OpenCV. We have OpenCV University supported by Big Vision. Again, this is a licensing arrangement. And OpenCV face recognition, it's a commercial face recognition solution powered by 7 Sense. Again, these licensing arrangements have been really helpful, but they are not enough, right? All these activities, they are not enough. We also have OpenCV AI competition, where companies like Microsoft and Intel have traditionally supported us. We charge a management fee for running these competitions, but most of the prize money goes back to the users. The biggest of them was this OpenCV AI competition in 2021 by Microsoft Azure and Intel, and we gave away 400K in prizes, and 1,400 teams around the globe participated in these competitions. It was a huge success, and we were able to connect with the community. So this was, it had many benefits outside just getting OpenCV funded. And finally, the last option we are exploring is crowdfunding OpenCV 5. And we have a history of doing these crowdfunding campaigns. In 2019, we did AI courses by OpenCV. This was the biggest Kickstarter campaign ever for any technical course. And this raised nearly $500,000 with the help of 1,300 backers. We also did a Kickstarter campaign for OpenCV AI Kit, and this raised $1.35 million with the help of 6,500 backers. But this campaign, was very successful, but not very financially successful for OpenCV because most of the money was used to actually fulfill the hardware. So now we decided, okay, we are going to go directly to our users for OpenCV 5. And that's why we are launching this campaign on October 31st. This is called Where is OpenCV 5 on Indiegogo. And if you have benefited from OpenCV, your career has benefited from OpenCV, I urge you to please personally help us drive this campaign. And also, please talk to your managers, your companies, and help us support the OpenCV library through gold, silver, or bronze membership. And our commitment remains firm. We are always going to be open source. We are always going to be free for commercial use. And we are always going to get the community together to do awesome things. So that's all I wanted to cover in this talk. Thank you.